remember, hopefully, that I said that rate of change meant the derivative of something with regards to time. So we're asking how something changed as time changed. And we're now going to look at a very special case of this, which is what we call kinematics, to do with distances. So the thing we're going to look at here is distance. And because D is being used for something else, which you actually know about now, because you've been doing a bit of calculus, you know why D is kind of a reserved letter, we're going to go with S for distance. So we have distance measured in S, and the question is, what happens as distance changes with regards to time? So when I'm saying, what is my rate of change of distance, the answer is speed or velocity. How fast am I covering distance? And if I cover a certain amount of distance, here I go, covering some distance. Consider that distance covered. And I'm going to do exactly the same. I'm going to cover exactly the same distance again. So there we go. What was the difference? The difference was that one of them took less time. So the rate of change of distance was slow on the first one and fast on the second one. So on one of them, my rate of change of distance, which you remember from that, was slow, and on the other time, it was faster. And that's exactly what you understand by velocity. Yep. So speed, velocity, those two things aren't quite synonymous, but close. So velocity is change of distance with regards to time. Yep. And then if I think about how I change velocity, so if I start speeding up, then I have this other thing, which is what we call acceleration. Yep. So acceleration is the change of velocity as time changes. Or this means we're differentiating this one again. So that's the second derivative of distance, and that's what we mean by acceleration. So sometimes it's quite handy if you can remember this. We chart speed, velocity, acceleration. And if you want to go across that way there, it doesn't matter whether you go from here to here or here to here, it's a case of differentiation. Yep. And later on in another video next week sometime, we're going to figure out what it means to go that way. So you can go both ways. But at this stage, we can only differentiate, so we're only going to be able to go this way. So we can then say things like a body has speed given by S at a particular time is 12t squared minus 3t plus 4. Something like that. That'll be a fair question. So we can ask things like how fast is it going after 2 seconds? Okay. So this tells us how far away it is from the start, and now we can figure out things like how fast is it going. And the how fast question is a velocity question. So velocity is change in distance divided by change in time. So just differentiate this sucker. Gives us 24t minus 3. So at t equals 2 seconds, velocity is plug a 2 into there. 24 times 2 is 48, minus 3 is 45 meters per second, okay, which is quite quick. 28 meters per second is 100 k's, so that's 170 k's or something like that. So it's going quite quick after 2 seconds. This is a very, very fast thing. So we could ask things like, what is its acceleration? Acceleration after 5 seconds. Okay, so the same thing. Acceleration is change in velocity over change in time. So we have to differentiate this one, and the answer is 24 meters per second squared. So it doesn't actually depend on time. It's constant acceleration. It's independent of time. Remembering that acceleration due to gravity is 9.81, so it's 24. It means you've got something which is accelerating pretty quick. It's accelerating 2.5 times the acceleration of gravitation. So this is what 2.5 g. You're talking about aeroplanes having g turns and all that sort of stuff. So this is 2.5 g effectively. So it's something which is pretty strong acceleration. But then you could answer all sorts of questions. You could answer questions like, at what time is the object stationary? Okay. Remembering stationary means no velocity. So we've got a velocity formula somewhere. Here it goes. So 24t minus 3 has to equal 0. So t has to equal 3/24, which is 0.125, I think, meters per seconds. It's time, isn't it? Yep. So after 1.125 of a second, the thing has stopped, and then by the time 2 seconds are going, it's going 45 meters per second. So it's a very, very quick acceleration type speed. But once you've got a formula for it, you've got full knowledge of its velocity, its acceleration, what time it's doing various things, simply because you can differentiate. And you know that to get from speed to velocity is differentiation, to get from velocity to acceleration is differentiation again. And that gives you a full set of tools to deal with moving things, which is what we understand by kinematics. So a really useful application of differentiation.